Uh, Sorry for the inconvenience because of some technical problem in the internet. That's a delay of the last session. Uh, Last session will be started by our resource person is Dr. MC Navdigi sir and HOD and Professor of Mechanical Engineering Department. Introduction will be later given and the session will be started. Hand over into the our resource person today, Dr. MC Navdigi sir. Sir.
Ready? Right. Okay. So good afternoon, everybody. So this is Dr. MC Navdigi, Head of Mechanical Engineering Department, BDA College of Engineering, Kalburgi. So today, this is my last technical session. You have enjoyed, I think you have enjoyed all technical sessions. So past 4-5 days. And now we are coming to a conclusion with my last technical session. Okay, so friends, so today we are talking, this is the FDP program on alternate fuels, especially biofuel we are just taking. And this one is organized under the sponsorship of the ATAL and organized by our Mechanical Engineering Department. So my topic is biofuel, which is called a green fuel for IC engine or a future fuel for IC engine. So as you know, the biofuel, so nowadays much of the research is going on the biofuel. So the 10th August is treated as a World Biofuel Day. So it is announced by the, it's an international day. So actually we thought of starting this program on 10th August only. So as it was Biofuel Day, but unfortunately we couldn't do so. But now we have organized this after a week. So here I'll be, for this 1.5 hours, I'll be taking the session, technical session, which contains the introductory part of the biodiesel, the need of biodiesel or the alternate fuels, but why we need this fuel at all, and what are the relative advantage or disadvantage, and the different process involved in the production of biodiesel. Then we'll be briefly discussing about the properties which will be required for the fuel to be used in the IC engines for the transportation sectors, and the good property and the bad property of this. So in all we'll be discussing in detail. And then the biodiesel, as you know, so it is a green fuel. Green fuel in the sense, that means it has a low emission compared to the petroleum products or petroleum fuels. So hence it is called as a green fuel, so which is the healthier from the human point of view and also the environment point of view. So in detail, we'll be discussing in this technical session. And if time permits, we'll take up the case study. That means how this testing is done and how the various, that means biodiesels are compared, what blending is suitable, and why the variation occurs, all these things. Some experimental data that what we have done in our laboratory, so that we'll be discussing if time permits. Okay, so as we say, that is a biofuel or any fuel, so which is required for producing the power or the energy. So now a present day, that means the transportation demand, that is much of the fuel is required for a road transport. As you see from this, that is about 3 million tons of billion tons of the fuel is required, or it is utilized by the road transport itself. So hence, in this respect or in this way, the fuel is a very important criteria or important aspects. So for the development of the nation. By 2035, we can see there is a tremendous increase in the road transportation. That is the demand, the fuel required for a transportation sector compared to the others, as you just see from this picture. Now, why at all? The question is, why at all the alternate fuels are required? Why we need to find out the alternate sources? So there are, now you can see the petroleum products, diesel or petrol. So it is depleting at a faster rate. And also there is a tremendous increase in vehicular population. So it is increasing exponentially. And also the industrial growth is taking place nationally and internationally. And then, so all these gives rise to, or this tends to make the energy demand, growing energy demand, and this will put the nation extra burden. Okay, so economically, okay, and financially, so this will be an extra burden for the nation. So for this, we have to import the crude oil from the other countries, and then also the much of the fuel is required due to the explosion of the population, tremendous increase in the population and the vehicles. So that requires the fuel, much and more fuels. All these means increase in the fuel or industry that leads to the environment pollution. So in this way, so we have to have search for the fuel which will have the lesser and lesser the emittents. So this is one of the criteria that we need. And then, so this is why it is required. So because that will have the adverse effect on the human being and also on the environment. So for this, the government is putting a stringent emission norms. So for this, in this connection, so we have the fuel, a green fuel, which will emit a lesser emission, so lesser pollution, so that it will be eco-friendly. So all these reasons together makes us to find out the alternate fuels. So in this, okay, so alternate fuels, there are many types of alternate fuels. So among that, the biodiesel is one of the major, the source that what we find. So now the biodiesel, as you see the scenarios comparing in the 2010 and 2035. So the biofuel rate, that is consumption rate, if you see, it was only 17.9% compared to the other sources. By 2035, it would go up to 30.4. That is what it is predicted. So that means the biofuel utilization will be increasing day by day. So thus, the research in this field is a very must. So the biodiesel, okay, so it is a renewable type of energy. So any country, so since we are agricultural nation, so there we can grow the vegetables, okay, or the plants which will yield the oil, and that oil can be converted into the biodiesel. So any fertile, so this for these plants, fertile lands are not essential. Any land is required. Okay, so for example, the neem tree or the cotton seed. So cotton seed, okay, so we are producing a lot of cottons, and their seeds we can utilize it for producing the biodiesel. So like this, any vegetable you take or any the tree or neem tree or the other trees, so some of the trees they require a non-fertile land, so which is abundantly available, so that we can utilize in this aspect. So in that way, so that means if you see the biodiesel cycle, that means the biodiesel, that means it is yielded or it is extracted by the seeds produced by the plants. So plants which in turn take the sun energy, convert it into the energy, that means photosynthesis process, and then so this after extraction we get the crude oil again refining, so that we get the refined oil, and then with the trans-esterification process we convert that into the biodiesel. So again the waste product what we get in conversion, so that again can be utilized for the other purpose, like it can be used for used by the food industry or cosmetic industries. And then this biodiesel, which has the same property as that of the diesel, so can be used for running the automotives. It can be used in the IC engines. Right. So this is how the cycle is. Again, the emission of the vehicles, so that means carbon dioxide, so that will be taken care by the plants again. So for photosynthesis process. So like this, the cycle is completed. So in this way, this is a eco-friendly. So this all these together, so that is the advantageous. So so whatever I have explained, so this is it is narrated here. There is a fast depleting petroleum sources or increase in petroleum prices or it's a non-renewability or contamination of environment, threat of global warming. So this has generated interest in developing the alternate fuels for engines, which promises a harmonious correlation with sustainable development, energy conservation, management, efficiency, and environment preservation. So over the next 25 years, so the demand for the petroleum products is expected to increase more rapidly in the transportation sector or the industry sector. Or so mainly in the transportation sector, it will be very high. So as we saw in the first picture. To cope up with this increasing energy demand, the majority of developing countries, so what we are doing, so we are importing the crude oil from apart from the indigenous production. This puts extra burden on the domestic economy or national economy. Therefore, so we have our attention is focused on developing the renewable or alternate fuels to replace the petroleum-based fuel for transport vehicles. It is therefore important to have a long-term plan to development of the alternate energy sources in a balanced manner by making optimal use of available land or the manpower sources. Technology is now focusing on development of plant-based fuels, plant oils and fats as an alternate fuels. So this is how all these has made us, that means other than that, that means the liquid fuels, that means the biodiesel is a liquid fuel, so it is more convenient to use in the vehicles or for the transportation sectors. The prime liquid alternative fuels are alcohol and vegetable. Alcohol cannot be used, it is not suitable as it is having a low C10 number. So that will lead to abnormal combustion, and hence we cannot use it as a fuel. So we are left with the vegetable oils. So most of the vegetable oils are having the properties which are close to the diesel fuel, and this has prompted us to use directly in the existing diesel engines. So and one more advantage, that means these vegetable oils are rich in oxygen, so they have the oxygen more oxygen, so that will raise the stoichiometric fuel air ratio. So only thing, the vegetable oils, they are having a less energy content, or what we call it as a calorific value. So it is almost 90% or 85 to 90% of that of the petroleum products or petroleum diesel. So thus, as we see, the alternate sources of energy. So there are many types of alternative fuels. So among them, the biodiesel is one of the major part. So where we are producing nowadays with the abundant quantity. Alcohol, okay, so that also will produce, but it cannot be used. It's not so suitable for the IC engines, and also the biogas, since it's a limited production of the biogas. Again, biodiesel, so it can be produced either from any seeds which contains the oil. Again, seeds means there are two types, edible and non-edible. Edible seeds are not preferred because that will lead to the deficiency in the food stock. So hence only the non-edible seeds like the cotton seeds or the castor seeds, so or the neem seeds, so that can be used for producing the biodiesel. So these seeds are subjected to the extraction process whereby the crude oil is extracted, then it is filtered, then it is subjected to transesterification process, and thereby producing the biodiesel. And the byproduct of this that is used for producing or making the seed cakes or the cosmetics or the soaps. And this biodiesel, which is produced, so it is filtered, making the bio oil, and then again upgrading for the various properties and making it suitable for using it in the diesel oil. What is this actually, biodiesel? Okay, so as per the definition, so biodiesel refers to a non-petroleum based diesel fuel consisting of short chain alkyl, either methyl or ethyl esters, made by transesterification of vegetable oil or animal fat, which can be used either alone or blended with the conventional petrol diesels in unmodified diesel engine vehicles. Right. So this is not a new thing. Biodiesel is not a new thing. It is it has been used since 1900. That means by Rudolf Diesel, who has invented the first diesel engine, and he used peanut oil for his engine. And after his death in 1913, development focused on the use of petroleum-based fuel only, and thereby so that the invention on the vegetable oils has been stopped. So as per the saying, so the Rudolf does, so the use of vegetable oils as in engine fuel may seem insignificant today, but the such oils may become in the course of time as important as petroleum and the coal tar products of the present time. So this is rightly said by Rudolf Diesel, which is true. Now it's coming true for the present situation. So these are the food stocks for the various countries that they are using it. So like the India, so we are the major production of the jatropha and also the waste oil. So much of the research is going on, and also the many more transportation and all those things. So presently the jatropha biodiesel is being used for the various applications. So like the China is using jatropha again, Brazil soybean, and America. So USA, so they are using soybean as a major biodiesel, and they are running their transports, the public transport presently on the soybean with a blending of 20 to 30% of blendings. So like this, all over the world. So whatever the major production is there, so major the crops are there. So based upon that one, they are using the biodiesels. So this is what it shows. So the sources of, as we just discussed, the ethanol can also be used as a biodiesel, which can be mixed with the petroleum products, which is obtained from molasses, wheat, or sorghum, sugar. So sugar industry, so there you can produce this ethanol. So, and the vegetable oils, again, as I said, rightly said, it's from the non-edible seeds, it is extracted. So like jatropha, so that contains 30 to 45% of oil. So then karanja, onga oils, Deccan hemp, cottonseed, neem, castor oil, moas, kokum, and simura. So all these, so the majority of the vegetable oils, they contain 30 to 40% of the oil in it. and that can be extracted and that can be converted into the biodiesel, and very effectively it can be used as a fuel for the engines. So as far as the properties are concerned, biodiesel properties are concerned, that means how it is suitable for the engines. Okay, so some properties are suitable and some properties are not suitable. So if the properties which are not suitable, so that can be converted or that can be made safe to be used in the vehicles. But majority of the properties, they are similar to that of the diesel, or they are advantageous over the diesel. Okay, petroleum diesel, like a flash point. So flash point of the diesel or the petrol, if you see, it is about 60 to 70 degrees centigrade. But here, whereas here, the flash point of biodiesel, that varies from 93 to 150. So it is in this way. So it is very safe for a transporting or for the transportation purpose. So it can be very easily carried out. So either flash point or the fire point, what you call. So these are the safer, very advantageous point. Then the water and sediment content in that. So with this, the water in the biodiesel could make the fuel go rancid and after the chemical structure of biodiesel. If the moisture is allowed to accumulate for a longer time, it will increase the free fatty acid level of the biodiesel. So that means the oil will settle down, or it forms a gummy product. So free fatty acid may corrode metal parts in the fuel line. So this is a very disadvantageous for the purpose of the flow in the metallic pipes. They can also react with the monoglycerides. So then the kinematic viscosity wise, okay, so this is the only disadvantage that is with the biodiesels. Okay, so or the vegetable oils. So the kinematic viscosity of the oil is very high compared to the conventional diesels. Okay, so this hinders the operation of an engine. So it hinders the flow through the pipeline or in the pump, and thereby the hinders the performance. Then sulfated ash, so is a measure of ash formed from inorganic metallic component. When biodiesel burns, it leaves some ash from unburned hydrocarbon and from inorganic compound. This can cause serious damage to the interface between the piston ring and the cylinder. So carbon deposition will take place, or the gummy product will be formed, and thereby which hinders the operation of the piston. So then the C10 number indicates how well the fuel will combust inside the compression ignition engine. So biodiesel usually has a higher C10 number than petroleum diesel. The C10 number of biodiesel varies from 45 to 67, so which is very, very close to petrol. So in that way, so it is good for the IC engines. Then cloud point, it is the temperature of the fuel at which a small or solid crystal can be observed, or it is formed as the fuel cools down. So the temperature so that means at the lower temperature, the crystals are formed. Okay, so hence such fuels cannot be used at the lower temperature regions, right? So wherever the temperature is very low, so that the crystal formation takes place and the oil will become thicker and thicker. So density will, the viscosity will increase. So biodiesel, that means tends to freeze at higher temperature than petrol. So this is one of the major factor hindering the use of biodiesel. The cloud point is well correlated with the filter plugging point, which occurs when the fuel begins to clog filter and hinders the operation of the engine, right? Then calcium, magnesium, okay, so that are there. Okay, so they are almost same as that of the petroleum products. Then the glycerin, then oxidative stability. So that means the oxidation of the biodiesel can produce various acids or polymers, which in high enough concentration can cause fuel system deposit and lead to filter clogging and fuel system malfunctioning. So additives designed to retard the formation of such acids or polymers and can significantly improve the oxidation stability. And the performance of this can be improved. And then the lubricity. Okay, so in this way, the biodiesel is the best one. Biodiesel has the high lubricity feature than the petroleum-based diesel fuel. Therefore, this may reduce the need for lubricity additive in petroleum diesel. Okay, so when biodiesel is used as additive in diesel fuel, so in that way it is advantageous. Then looking for the advantage and disadvantage. Okay, so in many previous talks, I think they have talked about this. So the biodiesel, so it's a non-toxic and biodegradable. Then it has a low greenhouse gas emission than diesel, very low emissions. Okay, so it will not affect the environment or the human beings. Then they are produced from renewable sources. It is the vegetable oils. Okay, so thus, so it can be recycled, and thus it is called as a eco-friendly oil. Then it has the biodiesel has a lower exhaust emission from the engine. This is the most advantageous. Okay, so what the present situation needs. Okay, so only thing, the power hampers. So due to the lower energy content, the power production will be lesser compared to the petroleum products. Better fuel properties than diesel, like a C10 number. Okay, no sulfur content, absolutely. So therefore, there is no production of sulfur oxides in the emission. Then lubricity. Okay, so lubrications, no problem. Then flash point, higher flash point, so that is very good property as far as the storage and the transportation is concerned. Then biofuels will ensure energy security of the country, so less import. Okay, so thus increasing the national economy. Then biofuels production will generate employment among the rural areas. The farmers will be enhanced. Okay, so more and more crops can be produced, and the unfertile lands also can be made use for the generation of this all. So thus this will improve the economy and also the employability of the rural areas. Then additional income generation for the farming community, so that will help them to improve their lifestyle. Then saving on the import oil and thus on the foreign exchange. Then greening of the land mass and ecosystem sustainability, so that will enhance. So in this way, the biodiesel is very advantageous and that can be made use. Only the disadvantage with the biodiesel is its storage for a long time. It is unstable. So if you store it for a longer time, so that will settle down and it forms, that means it is not suitable. Okay, so it is unstable oil. So this hinders the operation. This is only the disadvantage. And it becomes a gel in the cold weather. Cold weathers for the vehicle running in the cold weather, they are not suitable for it. It has a water content, that is the hygroscopic. It has higher NOx emission. This is one of the parameters. So compared to the petroleum emission, so only here the NOx emissions are higher. So about 10 to 15% higher than that. It increases the horsepower. As far as the use of the biodiesel, that means I just collected this one. So it is used for generation of the electricity, that means the generator engines. And also in the transportation sector, that means the railways, ships and automobiles, they are presently run on this, and the government has already implemented this. So recently the Boeing from I think Calcutta to Ahmedabad, so they have tried by blending 20% of the biodiesel. So the very successfully they run this, they have made the operations and succeeded in this using. And also the British businessman Richard Branson Virgin Voyager train in the London, so they are running on the biodiesel. And also the US government, they are running their public sectors or public vehicles on soybean oil. Okay, so presently they are running on this. So with a blending of 20 to 30% of biodiesel, right? So in the US, and most of the car, so they are running or they are using the biodiesel with the blending of 20%. Very safely they are using it. And then as far as the Indian scenario is concerned, so if you see, the first successful trial run of super fast passenger train was conducted on 31st December 2009. Delhi Amritsar Shatabdi Express, that has in that 10% of biodiesel is being blended with the conventional diesel, and thus seeing the total cost of that means running cost of the railway, that is 3,400 crores if for the diesel. So if at all 10% blending is done, then means we can able to reduce 10% of the cost. That means the cost can be reduced 300 to 400 crore per annum. We can save it. So the 10% substitution is acceptable. So for the existing CI engine, so there we can very easily mix 10%. So without any hardware change in that. So therefore, so very conveniently we can use this. Then Andhra Pradesh government, so that means they have entered into this sector. That means so with that means they have the agreement with the Reliance Industries for Jatropha plantations. The company has selected 200 crore of land at Kakinada to grow Jatropha for high quality biodiesel fuels. And Chhattisgarh has also decided to plant 300 million saplings of Jatropha in 16 districts during 2020, with the aim of becoming a biofuel self-reliant state by 2025. Maharashtra government also aimed to cultivate Jatropha on 600 square kilometer in the state. So HPCL so joined hands with the Maharashtra State Farming Corporation Limited for Jatropha seed-based biodiesel venture. So thus the Nasik and Aurangabad, there they have started the trial with a Jatropha plantation on 500 acres. Karnataka state is also producing a major sugarcane, and due to this, whatever molasses is produced from that, the ethanol, the byproduct is the ethanol, and that ethanol can be used as a major alternative to the petrol, and it's a boon to the country. Pongamia, in addition, neem, etc. So they are dominant in certain regions of the state. Tumkur, Chitradurg, Bidar, and Koppal. So there also, so these Pongamia is a major crop that is being produced, and also they are the major production of the biodiesels. That means ranging from 10,000 to 20,000 tons per year. So these are the different. That means the states adopting the different policies on the production of the biodiesel. This biodiesel, that means the oils have a good ignition characteristic. However, they cause a serious problem such as carbon deposits, as rightly I said, and which builds up on the piston coatings or the walls and all those things. So the major parts. Then poor durability, high density, high viscosity, lower calorific value, so more molecular weight and poor combustion leads to poor thermal efficiency. Right. So only the power production rate is slower. Otherwise, in other respect, that means emission wise, it is the most efficient, or what we call it as the most eco-friendly oil. We can rectify these problems. Okay, so whatever is there, so that can be rectified by just filtering it. That means transferring or converting it into the biodiesel and taking the properties very close to the diesel by trans-esterification process. So this is a reaction, so that already been, I think many have just explained this. So it's a monoalkyl reactions. So there, the triglyceride reacts with the alcohol and forming the biodiesel esters, and the remaining byproduct, that is the glycerin, so that can be made use in the other industries. Okay, so wherein the biodiesel, so that can be heated to 60 to 65, and thereby, so with the help of the alcohol, that means the catalyst, NaOH, sodium hydroxide or the potassium hydroxide. So there, with this acetyl reactor, so with this, the gummy product, so that settles down, and thereby the biodiesel, that the upper part, so that can be taken out, and again it is heated, that means to 110 degree to remove the moisture or the water content, and thereby finally we get the biodiesel. So these are the processes that means in the production of the biodiesel. So you can observe this. Okay, so most of the this one you can see, so the funnel. So there, after heating, and that means giving that after the settlement, so a biodiesel can, and a product can be separated out, very distinct separation, you can find it out, and thereby we separate it, and then it is subjected to the washing. So whereby the all sediments can be taken out, and thereby, so again it is heated and for removing the moisture content, and then it is dried, and thus finally we get the pure biodiesel. So these are the processes that are involved. Okay, you can see preparation of the biodiesel. So it is stirred. So this is a raw oil that is taken, and it is heated with a constant stirring. Then the separation of glycerol from the biodiesel, you can observe this. Okay, so then this is a reactor that we use it. So it is we have presently, it is installed in the Gulbarga city in the biofuel center. So there we have this center. So it's a reactor, so of about 30 liters per hour capacity. So that we have this, and finally we have the samples of biodiesel. So we have the complete setup in our institute, that means IC Engine laboratory, so which is a research center. So there many students they are performing their experiments for their the research work, and already the 10 students have been passed out from this institute, and they have taken the PhD degree on the biofuel. Okay, so friends, so this is the property which shows how these biodiesels are having the properties very close to that of the petroleum products. So viscosity wise, okay, so which is measured at 40 degrees centigrade. So the diesel is having about 3 to 4. Okay, so that depends upon the quality of the diesel. Whereas the raw oil, that means the pure, that means the without esterification. So you can see the viscosity, it is a 29 centistokes. So this one is having 16, 34, and 78. Castor oil is having a very, it's a very viscous oil, 78 centistokes. And after esterification, you can see how this viscosity has been reduced. So it is drastically reduced from 29 to 3.29, and which is very close to the value of this diesel. So thus here also you can observe this. So like this, so we can make the oil suitable for to be used in the engines. So the flow can be maintained with this viscosity. Then calorific value, of course, the calorific value of the diesel oil. So again, it will be around 42,000 to 43,000 kilojoules per kg. So again, it depends upon the quality. And there we can see these are lesser than compared to the diesel. So these are about 85 to 90% of that of the diesel. So its energy content is very less. So that's only the disadvantage. Then the density wise, okay, so these are the denser because they are the thick, high density oil. So therefore, and density, okay, so this one, then flash point, okay, so this one is having 78, and this, so okay, any of the flash point for the transportation sector, so the higher is preferred. Okay, so in that way, the biodiesel is suitable for the transportation. So this is how the biodiesel is more suitable for the transportation sector, or it can be very easily used for the IC. It can be used as a fuel for IC engines. And 10 to 20% blending is most safe. So that doesn't require any modifications, right? So therefore, very conveniently, we can add and we can use the engine, right? So this is about the overall overview of the biodiesel. Okay, so that I have just given the introductory part of the biodiesel, the advantage and disadvantage, how it can be made the suitable for the engines. Okay, so major advantage of this, what I said, it's a eco-friendly. That means it is a very, very safe. It is a green fuel. Okay, so for the environment. So totally the emission of this is very less compared to petroleum products. Okay, so in that way, just I have taken this emissions characterizations. Okay, so let us discuss about this. Right. So, what are the exhaust emissions or the emittents from the IC engines? Usually, it is a mixture of the fuel is a mixture of hydrocarbon. It's a combination of hydrocarbon. So it's a hydrocarbon fuels. So emission due to that one. So the higher emission, that is harmful emissions, are due to the incomplete combustion of the fuel. So that will increase. Then reaction between the mixture components under higher pressure and temperature. Combustion of non-hydrocarbons such as the sulfur and the fuel or the oil additives. Okay, so that leads to the higher emissions. Concentration of exhaust component may vary depending upon the engine and its load or the speed conditions. So you can observe this. Yeah, so very due to the higher vehicular populations and all those things. So that is polluting the environment more and more. So this is the chemical process. If you just look into this one, so hydrocarbon, that is the fuel. So that along with the air, it is being ignited, or the combustion will take place, and thereby the exhaust, that is the engine will emit these emittents. If it is a complete combustion, okay, so these are the byproducts, and incomplete combustion will to these byproducts. That means the more the nitrogen oxide, that means the NOx generally what we call, so that is the nitrogen monoxide and nitrogen peroxide, nitrogen dioxide. So these are the some of the, that means harmful the emittents that we find. And also unburnt hydrocarbon, so that emits, and carbon monoxide, which is very harmful from the environment point of view. So that will be more if the incomplete combustion takes place. Along with that, the smoke it contains. Okay, so these are the emissions that we have to take care. Right. So compared to the okay, so petroleum product, if we use the biofuel, so then these emittents can be reduced to a large extent. So here, so this shows the regulation, that means the SI engine and chains. Okay, so this is the CI engine emittents and the SI engine and the CI engine emittents. So carbon monoxide, okay, it's high. Only in case of the petrol engines, so NOx emission is less, and the particulate matter, so that also is less. So other two, that is carbon monoxide and hydrocarbon, it is higher in the SI engines, petrol engines. Then the gases derived, that means the hydrocarbon. So there you can see it. So how the phase change takes place. So these are the chemical reactions of forming the emittents. Carbon monoxide is one of the major issues. That means a poisonous gas, what we call. Okay, so totally it is due to the incomplete combustion of the fuel. Okay, so that can be controlled by having the fine tuning or by controlling the combustion. 10 to 500 parts per million, so that means ppm in case of diesel engine, so it emits, and 2 to 5% in case of gasoline engine, that is a petrol engine. It is basically a colorless gas, odorless gas, or toxic and flammable. At high temperature or the over-oxidation catalyst, that means it reacts with, that means, oxygen and then forming, so carbon monoxide reacts with the oxygen and then forming the carbon dioxide and thereby emitting certain amount of the heat. The oxidation of 1% CO in exhaust raises the gas temperature by 100 degree centigrade. So due to it's an exothermic reaction. And similarly, the nitrogen oxides, so formation of this one. So this slide shows how the nitrogen oxides are produced due to the combustion. So nitrogen dioxide plus nitric oxide, altogether we call as NOx. So the emission is of 52,000 ppm. Nitrogen dioxide, that is about 15%, and then in case of the diesel, and less than 2% in case of gasoline engine. At higher temperatures, so nitrogen reacts with oxygen and forming the nitrogen nitric oxide. And then at ambient conditions, so nitrogen, this nitric oxide reacts with oxygen and then forming the nitrogen dioxide. So again, generating certain amount of the heat. NO2 is a red-brown gas, so which by inhaling causes a respiratory problem or it causes eye irritation. Then it is a laughing gas as nitrous oxide, as I think all of you know. Then it has a low ppm. Then emission control device uses the PP, that is increase the nitrogen dioxide emissions. So it is important, in all, this nitric oxide is a major issue. Only this content is more in case of the biodiesel compared to the other one. Then particulate matter, okay, so this is particles, that is the carbon particles that is emitted. So again, it is higher or little bit higher compared to that of the petroleum products. Okay, so it's the solid fractions, so element carbon, so carbon content, and then ash content, then soluble organic fractions, so organic material from the lube, so from that organic material from the fuel, so that altogether it's called as a soluble organic fraction. Then sulfate particulate, so that means particulate matter contain the sulfate particulates, which contains sulfuric acid and the water. As you see here, as with the higher and higher loads on the engine, so the insoluble matter, okay, so that increases. Other insoluble matter, carbon dioxide, so that goes on increasing. And then the soluble organic fraction, that means the organic material from the lube or the organic material from the fuel, that tends to decrease as the load increases. In all, on an average, the total particulates, so that will be increasing with the increase in the load of the engine. Unregulated emissions, so that means all these, that is which contain the sulfur dioxide and metal oxides, all these things. Okay, so this is the overview of the emittents. Again, nitrogen oxide may the exacerbate asthma, so it leads to asthma because the respiratory problems, possibility of increasing the susceptibility to infections. Sulfur dioxide may lead to wheezing and exacerbate asthma. It is associated with the chronic bronchitis. Okay, so these are the diseases that it leads. Then suspended particulate matter, SPM, what we call. So that leads to wide range of respiratory systems. Long-term exposure results in death due to the heart and lung diseases. Particulate can carry the carcinogenic material into the lungs. Carbon monoxide, okay, so it's a very poisonous. With the more and more inhale, so it causes lethal at high doses. at low doses can impair concentration and a neurobehavior fraction. Okay, so like this. So the things, that means the emittents will cause the many more effects on the human life, like ozone, so that irritates eyes and air passages, increases sensitivity to the airways, to the allergic trigger in the people. Okay. Then the smoke emission or smoke opacity, what we call. So it's a visible black smoke, right? Increase with the load, rich mixture, combustion, and reduced oxygen. Then it can be reduced by using the EGR, exhaust gas recirculation. Then soil advancing injection timing and improving atomization, so that can be. Then smoke and smoke opacity meters that measures the optical properties of the diesel exhaust. Low cost and widely used in instrumentometer quantity of the visible black smoke emissions. So these are the emission norms that we use. Measuring the vehicle emissions for regulatory purposes, federal test procedures. So these are the tests that are carried out in order to specify or in order to fix up the emission norms. Okay, so like the light duty vehicles or chassis dynamometer and the driving cycles that are used for measurement of the smoke emissions. Then heavy duty vehicles, engine diameter and the operating cycles that are being carried out. Then the emissions are controlled, emission controlling boards. So that means technologically feasible but not demonstrated. R&D required to commercialize a new technology to meet these standards. Okay, so they are fixed. Then these technology they follow, emission levels can be met with demonstrated technology. Technical and financial risk are lower. After treatment, devices developed should meet the emission norms throughout the vehicle's lifetime. Okay, so that's called as emission norms that we call. Then emission factors, which are vehicle emissions, are affected by driving patterns, traffic speed, congestions, altitude, temperature, other ambient conditions, and the type, size, age, and condition of the vehicle engines, fuel properties and the quality or the alternative fuels. So that also affects emission effects. Then vehicle and emission control equipments, maintenance. So the things that we affect. So this is how the testing is being done. So where in all the parameters of the exhaust can be measured, and thus so they are based upon these measurements, that means the emissions are put forth in order to safeguard the environment and also to safeguard the human beings, the life. So these are the category M, that means the category of light duty vehicles. So motor vehicles with at least 4 wheels and used for the carriage of passengers, category M. So the various categories are being done. So based upon the type of the vehicle. So category M1, M2, M3. So based upon this, the exhaust, the emission norms are put forth like this. Then these are the BS3 and BS4. So how much the CO, HC, NOx, and particulate matters are to be there. So that is being the government policy has been put forth. Okay, so this slide shows BS3. So for example, the CO. So it's a limitation for the gasoline engine as a 2.3 kg per kilometer, and for the diesel engine 0.6 grams per kilometer. Okay, so that is the category M category vehicles. For N category, so like this, the BS3 norms have been formulated and they are formed and they have been enforced by the government. So like this, you can see the vehicles that is designed or the engines which are put forth. So they are as per the BS3, BS4. Now it is BS6. So that are there running. So all these values have been put forth and they are enforced. Then emission standards in the European Union for the heavy duty vehicles, so Euro 1, Euro 2. So based on that, they are changing their norms. Then like 1992, so they come up with the Euro 1, 96 Euro 2, they are formulated, then 2000 Euro 3, then 2005, 2008, so Euro 4 and Euro 5. So these are the norms, European norms. Like, so again, BS3, BS4. So these are the limitations that have been put forth. Then relative emissions, what we just kept. Okay, so if we use along with the biodiesel, for example, so what is the relative emission? See here, if you can see, if you use the 100% oil, biodiesel, without any mixture or without any blending, so that will have the lower emissions. You can see lower emissions, right? So with the diesel product of diesel, that means petroleum products or petroleum diesel, so that is giving the more emissions. You can observe this in all these things. Okay, either the hydrocarbon or carbon monoxide, particulate matter, NOx, or the carbon dioxide CO2. Okay, so with the blending of 20%, so which what we are using in the present day, so 20% is the safe blending for the engines. So that will reduce considerable, the emission will be reduced with the 20%. And also this will give the saving of the 20% diesel. So in both way, it is advantage, right? Okay, so friends, so this is the emission that are there. So emission wise, it's a good for the vehicle. So in that way, so it's a more suitable fuel for the IC engines, right? So now as a case study, right. So here I'll just show some of the slides. So based upon our work, what PhD students have done. So just I have taken that work and to explain so how it is varying. Let's say as a case study. One. Okay, so this is the experiment setup what we have in our institute. Right, so it's IC Engine Laboratory of PD College of Engineering, Kalburgi. So here we have the PC based setup. So altogether, so it's a 5-gas analyzer. Then this is a TB1 engine, Kirloskar, having 5.2 kilowatt coupled with the exhaust, the eddy current dynamometer. And this is control panel. And then, so we also carried out the experiment with the blending of the CNG. So that also we tried, and the exhaust gas recirculation, that also we have the arrangement here. So we can have the various arrangements here to carry out the various performance test and also the emission, corresponding emission and combustion also we can read it. So this is a very the exhaustive experimental setup we have in our laboratory. So this is the specifications wise. Okay, so of the engine. Okay, so viscosity, as you know, so at the higher temperature, the viscosity drops down. At lower temperature, the viscosity of the oil will be higher. So the various oil. So this, what we have tested the different oils, that is castor, linseed, Nova, neem. So all these are compared with the that of diesel. So diesel is having a very low viscosity. And this graph, from this you can see that at about temperature of 70 to 80 degrees. So all the viscosity of the different oils reduced to, or they become closer to that of diesel. That means if at all pure oil is to, if you are using 100% biodiesel, you are using vegetable oil you are using, that needs to be heated to 70 to 80 degrees, preheating what we call. So that way. So this is preheating will make the flow easy. So, but preheating is very difficult. Okay, so again you have to heat the oil, and then that you have to put it in the tank, and then that you have to allow it to flow. Then the brake thermal efficiency. So if it is compared with that of the diesel. You can see the various the oils, that is the castor or the Nova or neem, linseed, they are having the similar trend as that of the diesel, right? So initially at the lower speeds, okay, so they are very close to that of the performance is very close to that of diesel. So as the load increases, so then they deviate much more from the diesel engine, right? And also at the about 75% of the load, so there the performance is very less compared to that of the diesel. And this reduction in the pains, this is due to the viscosity, the pains, the higher viscosity, so that makes the oil to hurdles the oil flow. It may also due to the better utilization of heat energy and a better air entrainment. In addition, the ignition delay time of the above blend is closer to that of diesel. So due to faster burning of the biodiesel in the blend, the thermal efficiency was improved here. Okay, so that's what. Right. So here in this case, we can see this is a biodiesel and this is a pure diesel. Only the raw oil, that is what we can compare it, and they are more trending towards the diesel. So the flow becomes easy and the combustion also will be faster. And as you see, the specific fuel consumption, the consumption of the fuel per kilowatt of the power, that was specific fuel consumption. You can see again for the raw oil and for the biodiesels. Okay, so the consumption, specific fuel consumption of all these biodiesels happens to be higher than that of diesel, because for the same production, power production, so due to the lesser caloric value, so large amount of fuel needs to be burned. So therefore, they are having the higher specific fuel consumption rates. Here you can see. So here also it is similar to that. So this depends also on the density, higher density and the lower caloric value that makes the higher fuel consumption. Right. By increasing the biodiesel portion blend, which increases the viscosity of the fuel, so which increases the fuel consumption. So blending, you can see it. So 20%, 40%, 60%, 80%. With the more and more blending, so the more and more specific fuel consumption that we observe it, because the density and viscosity goes on increasing. Okay, so due to that, that leads to the higher fuel consumption, and also which will make the poor automation of the fuel. Then variation of the exhaust gas temperatures. Okay, so it is here also you can find it in this. Okay, so higher. So as the load increases, we get the higher exhaust gas temperature. In case of the vegetable oil, so that is due to the high heat release rate and also maybe due to high oxygen content, which improves the combustion. Right. So exhaust temperature of that means some of the oil, that is, for example, here in this the linseed what it is showing, so it is higher. So the possible reason for this increased temperature may be relatively higher availability of oxygen in the biodiesel for combustion. And also because of a full load, the chemically correct ratio of air and fuel is used. High heat is generated inside the cylinder. So that leads to higher exhaust temperature. And then carbon monoxide wise, so you can see this from this graph, we can say that 100% of biodiesel, that means without any blending, the carbon monoxide is more as compared to other blends. This is because of the high viscosity, poor atomization that is tending to lead the poor combustion and higher carbon monoxide. So variation in the unburnt hydrocarbon. So you can see this. So this has given, that means the EGR is widely used to reduce the oxides of nitrogen, oxides, thereby reducing the unburnt hydrocarbon. So this leads the more emission of to increase the emission of unburnt hydrocarbon. 5% ethanol alcohol is added. So that combustion will be proper, and thereby the rate of hydrocarbon will be reduced to a larger extent. NOx. Okay, so as you know, so NOx is the element which is emitted higher compared to the diesel. So the main reason for higher NOx production is due to the temperature and the duration of the combustion flame due to a burning of mixed fuel air. Due to increase in applied load on the engine, emission of NOx rate increases. The increase in NOx emission may be due to more oxygen present in the biodiesel, resulting in a peak combustion temperature. Okay, so this is how some case studies, just slides, I have just added it, all these together. So finally, we can conclude that the use of about 20% blending of biodiesel with the conventional diesel, so that will not require any engine modification, right? And also the use of biodiesel, so that will generate the agricultural enterprises and also rural employment. That's what we have seen it. And then the biodiesel, with the mixing of biodiesel 20%, so with the help of that means that saves 7.3 million tons of diesel per year. So thus increasing the economy. In India, about 33 million hectares of wasteland is available, and that can be made effectively used for the cultivation of the jatropha or the other plants, which yields the seeds, giving the vegetable oils. So in all, so the biodiesel is very helpful, or it can generate employability, it can reduce the economy, it will reduce the input. That means the import of the conventional fuels, it will increase the economy. So all these overall, the biodiesel use of biodiesel will be very green, neat and green fuel for the future IC engines. Okay, friends. Okay, so now, so it's already 1:35. So at 2 o'clock, so our validatory function will start. Okay, so in that way, so you just 10 to 15 minutes, within 10 to 15 minutes will be preparing all these things. Okay, so now I'll stop this presentation for this. Exactly at 2 o'clock, the validatory function will start. So all are requested to attend this.
Thank you, sir.
Okay.
Just thank you for wonderful session. The participant, any questions regarding this session? Just ask the questions.
Okay.
Just ask the question regarding this session. Sir will be answering. Right. Ask the
Hello.
Hello.
Yes, sir. Good afternoon, sir. Am I audible, sir?
audible.
Yes,
Ask
sir. Yes, sir. Thank you, sir, for your nice presentation, and which is easily understandable, sir. I am Ravindra Kumar Mahato from South Asian University, New Delhi. Sir, my question is, sir, is only the viscosity is the factor that we are not using 100% biodiesel, sir, because the government has the concept of blending the biofuel in a different ratio. And from the previous talk also, I came to know that if you are using 100%, then the engine efficacy, and there will be the risk that we have to again use the diesel in the engine, sir.
Yeah, Ravindra. So it's a major issue is with the viscosity only, right? So that is a major factor. So that hinders the performance. Otherwise, all other properties of the biodiesel, they enhance the engine performance. Okay, so they are the helpful, or they are the advantageous, right? For the viscosity only, we are using the trans-esterification process. Again, it's a costlier process, right?
Yeah.
So the Indian government, so that is what they are trying to reduce this. So in the mass production, the cost of the production of biodiesel, so that may come down in the mass production. Right. So in future, so all the vehicles, that means the major engines will be running on these biofuels only. Right. Okay.
And yes, sir. And so I think due to the yield or productivity also, because we have less production, so we are
Yeah.
not able to use 100%.
Yeah, yeah, sure.
Because yeah,
That's
and
all.
it,
Yeah,
the
presently we
cost
don't
is
have.
also very. So I
Right. Presently, we don't have that much technology. So with the improvement in the technology and all those things, so we can produce, and also the seeds, that is availability of the crop or the seeds. So there's also, so we have to cultivate, isn't it? So the government is taking initiative in this regard. So they are cultivating more and more trees on the unfertile lands. Okay. So as rightly I said, so in some of the slides I shown all the states, giving the scenario of the different states of the India. Nowadays they are improving. Okay, so within a couple of decades, so we may come across the diesel, okay, biodiesels everywhere. So we have the stations, isn't it?
yes, sir. Thank you, sir. And one question is, sir, what are the major problem in commercialization of this biofuel, sir? Because wherever we are listening the talk, every talks are on the research scale. So what are the major bottlenecks, sir, in this when we have the commercial plant of the biofuel in the India? Because the abroad they are have the but we are lagging behind that. Whether we are agriculture country, we have the land also, we have the but why we are lagging behind that, sir, commercialization, sir?
Because awareness, it is a lack of awareness, because our farmers, so we have to make the farmers and things, so that we have to make it aware. So Indian government, again, they are just focusing, they are giving some programs, such programs they are arranging, so that the farmers should come forward to cultivate or to generate these seeds and everything, isn't it? And also the government should develop the proper technology in order to purchase this, and then that convert into the biodiesels and all those things. So we are having the lack of technology and also the lack of production of such bioplants, isn't it? So presently, but slowly, so I think it's improving. Okay, so earlier it was very slow, but nowadays with the awareness of this one, so more and more improvement is taking place.
Okay, sir. Thank you, sir. Yes.
Okay.
Any questions, participants? Just unmute your audio, ask the questions regarding.
Okay, I think no more
questions. Thank you, sir.
Yes, sir.
Ask.
Yes, sir. I have one more question, sir.
Okay.
Now in this engineering department, they have the facility of testing the biodiesel. Na? Suppose
Right.
if others lab are working on other biofuels like the butanol, biohydrogen, then if we want to have the test on the engine or maybe the any, so where we can have the such testing research facility, sir, directly we are.
Right. Okay. So what's your name, Professor?
Ravindra Kumar, sir. I am PhD students.
Okay, so Ravindra Kumar. So many students, they are now, they have set up, they have their own setup. So like our PD Engineering College, so we have the research center, so exclusively for IC engines. There, we have the completely PC based setup. So complete, that means data is interfaced with the systems, and no need, only you have to vary the loads and all. So any oil, that means either if you want to take up the readings with the raw oil, so for that also we have the heating arrangement. So directly the oil will be heated in the tank itself, and then that is made to flow. So like this, on the raw oil, that means 100% the oil, even without esterification. So that also you can take the performance readings. And not only performance, you can take the emission, that means 5-gas analyzer. Again, it is a PC based, so completely data will be stored. And then the emission, combustion, and also the performance. So like this, many institutes are set up in such lab facilities. So among them, so our college, PDA college is one. So all over from South Karnataka, India, the research scholars are coming here and they do their work, experimental work, and they go. So for that, we just charge nominally. Okay.
Yes.
So in that way, it will be helpful for the other students. Okay, so that part. Okay, so many are there now. Okay, so institutes like in Maharashtra, even Apex Innovation, so who are the manufacturer of these setups. So they also they have the such laboratories. So sometimes we send our students there also for taking up the results. Okay, so like this, institutes are coming up.
So, okay. Yeah. Thank you, sir.
Okay. Right. Okay, Harish.
No question, I think. That's conclude. Thank you, sir. Very good session for this. And I conclude this last session of the 5-day FDP. I'm taking break for 20 minutes. Exactly 2 o'clock. We'll start the validatory function. All the participants join. It is finishing in 15 to 20 minutes. That validatory function. All are invited to using this link. Join the exactly 2 o'clock. Validatory function will be started. Thank you very much. Thank you, sir.
Thank you.